People nowadays rely on computers for pretty much everything. We use it for calculations, education, automation, communication, and even entertainment. However, it's not as often that we realize how our series of commands undergo a complex array of systems just to fulfill a task at hand. Hence, the computer-to-human interaction system model. This system both includes living and non-living components. Non-living would be the electronic system of the computer, while living would be the biological system of the human who both gives and receives input and output to and from the computer.
For the electronic system of the computer in this model, everything starts with the power grid. It is a complex system in itself, but in this model, its sole purpose is to provide energy to the computer so that the task attributed to it can be accomplished. Next, it comes to the PSU or the power supply unit. This makes sure that the unit is not receiving too much or too little voltage. This connects with the external monitor and to the motherboard, which organizes and diverts power into all the peripherals connected. These peripherals in turn will now function systematically to handle work. The RAM stores short-term data, ROM stores long-term data, CPU processes instructions, and GPU renders, while the keyboard, mouse, speaker, and monitor relays and receives input and output from the electronic side of this system into the biological part which provides the task.
The living system in this model, however, is composed of the hands, eyes, and ears, which interact with the computer. These parts later on relay the information they received through the nerves into the brain, which then processes it to relay new tasks. This system, however, is only possible due to the seamless work of the various body systems, which in turn rely on a stable supply of water, food, and oxygen.
In this system, every component has a counterpart that it affects in a particular way. For instance, there is a sense of mutualism as the CPU sends information to the motherboard and as the motherboard provides power to the CPU. However, not all components affect all other components. An example of which would be how the motherboard affects the speaker in order for it to produce sound, yet the motherboard is unaffected by the speaker. In summary, all system components can be seen to have an output that affects the receiving end, but not all components can be both the sender and the receiving end at the same time. Despite these differences, each component remains extremely important and contributes significantly to the system's efficient operation.
The parts together does produce an effect that is different from the effect of each part on its own, in a sense that within the electronic system of this model, the complexity of a task being processed relies on the effect of the presence and simultaneous activation of each individual part available. The same thing actually goes with the biological system of this model as well. For this one, each and every part has a task to do. Individually, they do different tasks, but in the bigger picture, they perform a different function which is in a higher scale, way more complex and different from the task that each part does individually.
Certain circumstances can hinder the function of the system, be it momentarily or permanently. For example, if there is a problem in the power grid, say a brownout, then the whole system will not function until the power is restored. Same goes for the components of the computer system. If one is broken, then the functioning will be compromised until the broken part is repaired or replaced. As long as the parts are functioning well, then the behavior will persist over time. However, we cannot expect that the performance will continue to be the same all throughout. Take the computer ROM for example. As we continue to use our computers, the files in storage are bound to increase. Thus, as the ROM stores more memory, the computer's functioning will slow down unless you free up some space. We can say that the computer system's effects and behaviors will continue to persist if we make necessary adjustments depending on the circumstances.